Long division can be a tedious process, but fortunately there's a shortcut we can choose to use if the divisor is of the form x minus c. I'm going to show you the process here and then list the steps for you to hopefully make it a little easier. This is vitally important, though, that you use synthetic division only if the divisor is of the form x minus c. Notice here when we do long division, we have to get the coefficients to match. We multiply everything through. When you're doing synthetic division, you take the c value, which is going to become the 2, and then you list the coefficients, putting a 0 for any degree exponent that's missing. And then the first step is you just drop the -2 down, and then I'm going to multiply. 2 times -2 is 4. And now we'll add, which leaves me with 4 here. Then I'm going to multiply again, which gives me 8, resulting in a -1. Multiply again, -2, which leaves me 5. This last value is your remainder. And what you will find is that these now become your coefficients. And then it drops by a degree of 1. This was degree 3, so this becomes degree 2, degree 1, and 0 with a remainder of 5. So what are those steps and how can you remember how to do them? Verbally written out, first of all, always make sure that you're of the form x minus c for the divisor. If so, you're going to write c followed by the coefficients of the dividend, and that's what we did in this step here. Then you're going to write that leading coefficient on the bottom row, and then you'll start that process of multiplying, place the product in the next column, add, and repeat. That final value is the remainder, and the bottom row values are the coefficients. And note again that degree is 1 less than the dividend. One thing I want you to make sure you recognize here, PC is the remainder, that last value. If PC is 0, then we know that C is a 0 of P of X, and we know that X minus C is a factor of P of X. So if this last term comes out to be 0, that gives us a lot of information about that polynomial and its factors. So let's use synthetic division in an example here. If I want to divide P of X by X minus C, that tells me that C is 5. So I know that 5 goes out here, and then I'm going to list my coefficients. Notice I have all of the exponents, so I don't need any placeholders of 0. I drop down my -2, and now I begin multiplying. 5 times -2 is -10, leaves me with 1. 5 times 1 is 5, which leaves me with 0. 5 times 0 is 0, which leaves me with -3. 5 times -3 is -15, which results in 0. This tells us several things. 5 is a 0 of P of X, and that's by the remainder theorem. We know that P of 5 is equal to 0, and we know that X minus 5 is a factor. Notice then this allows us to write P of X is equal to X minus 5 times, these are our new coefficients, -2x, 1, there's a 0 there, and then a -3. I like to start, this is always going to be my constant. I had no 0 term, so then I have x squared and then x cubed. This was my x term, x squared, x cubed, if that helps you write the format. Let's do one more where there's an imaginary number involved or a complex number. Remember that divisor still has to be first degree. This is our divisor. Our C value here is 1 minus I. So we're going to do the same process. We put C out here. We're going to write our coefficients of -3, 5 minus 2i, -4 plus I, and then 1 minus I. Again, there are no zeros because there are no placeholders. I'm going to drop the -3. When I multiply out, I get -3 plus 3I. I add those together to get 2 plus I. Now I do have to FOIL this to multiply it out. And when I do that, I get 2 minus I plus 1. Combining like terms there, notice my i's cancel, and I'm left with -1. When I multiply that out, I get -1 plus I, which does result in 0. I'm going to go back and put in my degrees. This is going to be my constant term. This is going to be my x term, and this is going to be x squared. So I end up with -3x squared plus 2 plus ix minus 1. And we know that x minus 1 plus I is a factor.